Hello everyone, and welcome to this video for PROG1198 Client Server Solutions. In today's video, we're going to look at an introduction to creating scripts in TSQL. So our goal is to create one script file containing many SQL commands that can be executed to create or modify a database and/or its objects. When we create a file, we want it to be able to execute from beginning to end independently. That way we can execute the file without having to have a user running different bits and pieces of it. It's like a program that we just want to be able to hit run and it does its thing on its own. So if we create a script file, we have to write it in such a way that the code follows along step by step, and the code that executes before needs to successfully complete before the next step happens. So any of the SQL commands that are appearing together in a script are all executed as one unit, unless you separate them into batches. So we can group commands together called a batch, and that way the commands that need to be completed successfully before other commands can execute, we can do the code in parts by splitting it up into separate batches or execution units. One typical example of that is when you're running create statements, and then you're running statements after that that depend on the objects that you created. For example, if you create a function and then you call that function, you need to make sure that the code that creates the function has already executed and completed successfully before you move on to calling that function. In order to create a batch using SQL Server Management Studio, we use the go command to separate code into batches. One thing to note is that go is not a TSQL command. It's not part of the SQL language. It's a command that's recognized by the Management Studio application. And you can actually change this command in SQL Server Management Studio to be anything that you want. So you can control what the batch separator is. However, go is the default, and there's really no reason for you to change what the default value is. So whenever the query editor comes across a go command, it sends all the preceding commands to the interpreter for execution. So those commands are executed before the code moves on. Now, it just goes back to the last go command, or if one was not present from the beginning of the script. So in my SQL Server Management Studio, my first command here is use username company. So I want to switch to this database. And if my next command depends on something in the username company database, typically we would choose to put a go command to make sure that we can successfully send this through and that the script continues, because if we encounter an error, the script will stop executing. Now, you don't need to use go commands to separate everything. The interpreter only requires a go command after certain create statements. And the reason for that, of course, is because if something hasn't been created, then how can you plan to use it? However, go is typically used to execute the script in pieces, even if it's not required. You may have noticed go in some of the scripts that I've given you. In the database scripts part, there's a lot of go statements, typically between create statements or whenever you're switching to and from a different database. So we're going to talk a little bit about TSQL. It's short for Transact SQL, the extension of the typical SQL language. It's a procedural language. For the most part, we're just executing things in order. That doesn't mean that we can't transfer control and call functions and things like that. But what it means is that it's not an object-oriented language. So we don't create instances. We don't have things like static or anything like that. Things that we can do, though, in TSQL are a lot of the typical introductory programming things that we've learned, such as declaring variables, creating functions and procedures that we can call on, and working with decision structures and iteration structures. Iteration structures are pretty uncommon in TSQL, typically because most of the SQL commands we write, we can write them to operate multiple times or on multiple records without needing a loop. For example, if you have a statement that updates multiple rows, we already know we don't need a loop for that. We just need a where line that targets the rows that we want. And even if there's more than one, they'll all get updated. So iteration structures aren't too common in TSQL, but you can do them. We will touch on them very briefly. Most relational databases have their own procedural language support. So TSQL is not unique in that statement. Most relational databases, that is, databases that enforce referential integrity between tables, would have their own procedural language support of some type. So the first thing that we're going to look at in TSQL is errors. Error handling is really important. We want to make sure that, just as whenever we write any program, that we want it to be error-free if possible, or if we expect errors are possible, we need to write code to discover and respond to them. So we've got two types of errors that we're looking at, a compile error or a runtime error. So a compile error is the same as a syntax error. This is when the program statements do not obey the rules of the language. Typically, the interpreter reports compile errors if you execute the code and it cannot run because of syntax errors. You haven't formatted your queries correctly, or you're missing an ending or a beginning of a statement, or the columns that you're trying to use are not found in the table. There's all different kinds of syntax and compile errors. If you try to execute the code and there are errors present, they will be reported in the messages pane, and the batch of code is not executed. Typically, we can also use the IntelliSense in Management Studio to warn us ahead of time before we try to execute about errors that might happen in our program, and you'll see that happening with the red underline. So if I perform, let's say, an insert, and I insert into nothing, I don't have a table named nothing. So you can see that it's reporting this error, an invalid object name. This would be a compile error. If I try to execute this, we can see the compile error being reported down here in the messages pane. Now, the other type of an error is a runtime error. This occurs when your syntax is correct, but an error is detected by the database management system. So this is something that, for example, you have overflow in a field value, or there are other things that it's not a typo, but it's more of a logic problem. So when we encounter runtime errors, again, execution stops. The rest of the script command will not execute. Now, compile errors have to be solved before you can run the program. So if we have compile errors like, if I have, for example, this would be a compile error that, I've got a typo here, a mistake, and those kinds of things get reported down here. If we execute that, we see various compile errors being displayed to us. A runtime error will give you the same sort of result. Instead of saying message, though, it will say an error. So let's see if I can trigger a runtime error. Oops, I'm in the wrong place here. Let's insert. If we insert into employee, for example, and we'll put some values into here. I'm just going to expand my employee table to get a look at what type of values we need. So we need to supply emp first, emp last, and updated by and updated on. So I'll just pause the video while I type an update command or an insert command. Here we go. So I've typed an insert statement. The syntax is correct, but you'll notice that there's a logic error here. The size of emp salary is .92. We've got more than 9 digits here. So we are going to encounter a runtime error when I attempt to perform this insert. So we'll see that there's an overflow error in that area. And there are all different types of errors. For example, if I were to drop the employee table and then try to perform an insert into it, it's going to give me an error message telling us that that table is not found. So I'm assuming by this point, having a little bit of experience in TSQL, that we've seen errors before. But one thing that we haven't done that we're going to learn about today is generating your own errors. So when something goes wrong in the code, we actually prefer to get an error message. We want to know about it. That's the way that we can inform the user that something failed. And it's really important to inform the user when things didn't work as expected, because otherwise the user will go away assuming something worked when maybe it didn't work. So we want to be able to raise an error in TSQL. Now I'm going to show you 2 different ways to do it. And the first one is through this raise error command. So a raise error command, and you'll notice the syntax, even though there should be 2 E's if the words were separated, but it's all one word with just 1 E in the middle. It's kind of squished together, raise error. That statement allows you to generate an error message, and you can indicate what you want the message to say, and you specify the severity level and the state. If this code is reached inside a try block, the execution will transfer to the catch block, but only if the severity level is over 10. So we're going to talk in a minute about what the severity levels are. So you can indicate how severe this error is, and if it's not a big deal and you just want to have an information kind of a message, then you would put a severity level that is low. And if it's an extremely severe error that is a big problem, then you have a higher severity level. One thing to notice about using raise error is that it does not automatically abort transactions. Even if you've turned on the transact abort statement, it still does not cause the transaction to stop and roll back automatically. So if you're using raise error and you want to be able to roll back the current transaction, you need to combine it with a try catch block, and the catch block must use explicit rollback. So you can take a look at the previous video if you need a quick refresher on how to use try catch and to roll back the transaction. So in this example, I have an error being raised that says insert actions failed, and I've set the severity level to 16. That's the common default setting. And then we have this state. Now, this state marker here is used to indicate a location in your script. So it doesn't carry a meaning on its own. What it's used for is for testing and for other programmers to be able to find this error in your code. So if you raise the same error in multiple different places in your script, the state can be used to indicate which one of those caused the error. So if you have this same statement all over the place in your code, in various functions and in various different parts of the script, you would assign a different state value to each one, so that if you come across this error during execution and it says insert action fails state 5, then you know which one to go to. You know where the error was raised from. Now we can take a quick look at severity levels. I put this here as a link to the Microsoft documentation. They explain it very well. There's a chart there. So let's just click on that now. So it opens up this documentation here. The Microsoft SQL documentation, I think, is really, really good. So whenever you're searching for answers or examples, I always suggest go here first, because, unlike most native documentation, this one is actually, I think, really, really well done. So database engine error severities. You can see that 0 to 9 is an informational message. that reports errors that are not severe. We have here that 10 is an informational message that is not severe, but there's some compatibility issues there. 11 to 16, those are the ones that we're interested in. Those are errors that can be corrected by the user. So when we are raising an error to inform the user, those are the severity levels that we want to assign. So each one of those has its own meaning. So here we have some that are transaction related, some that are security related, syntax errors. 16, like I said, is the common default one, general errors that can be corrected by the user. We have 17 to 19 for software errors that are not user dependent. We have 20 to 24 for fatal errors, which means that the database engine is going to shut down. And in here, you'll notice you also have the option to user define your own error messages. So the raise error and the next one that we're going to be looking at as well, you can use this sys.messages catalog where we can store user-defined error messages rather than recoding them over and over again. Let me bring up our slides again. So rather than typing in a literal string like insert actions failed, you can go to that list of existing error messages and call on one of those instead. We're not going to look at those examples today, but if you're interested in expanding your knowledge more, there's a good place to start. So there's some other information here about retrieving the severity of existing errors. And the one important thing that I want to point out here, that errors with severity from 0 to 10 are informational messages, and they do not cause execution to go into the catch block. So we want to make sure that the errors that we generate have that higher severity level so that if you're in a try, you can go to the catch and then maybe roll back the transaction. Now here's another way of generating an error. It's similar to how we learned how to generate errors in C#. We can use a throw statement. So when you use a throw statement, this always causes the execution to go from the try to the catch block. You're not able to set the severity level manually. The default of 16 is used. However, if you're rethrowing an existing exception, then whatever severity level that one had comes along with you. So it's not always 16, it's just 16 if you don't define it. Now, you might be asking why you want to rethrow an exception. Well, it might be that you have code that deals with an exception somewhere else. So for example, if you have a try catch inside of a function or procedure, and you want your catch block to roll back the transaction, but you also want to inform whoever called on this procedure that, hey, we've got an error here, you can use your catch block and then rethrow that same exception again. In order to do that, all you need is the word throw. You don't need all the rest of this. When you're generating your own exception, which is the most common use here of throw, you assign it an error number between 50,000 and the int.max, maximum level for integer. This is chosen by you, so you can pick whatever number you want. Any numbers less than 50,000 are reserved for Management Studio to use, so those are taken up already by SQL Server, and they are supposed to be a number that indicates what type of message it is. Here we have the error message. I used the same one as the previous slide, and the state. So those are the same as the previous example. So we can put that code inside a try catch in order to generate an exception, force us into the catch block, and maybe roll back the transaction. Let's take a look at an example. So I can use a transaction to encapsulate this code. We will try to commit the transaction. Now, because I want to use raise error, I'm going to put this all into a try block. So we have begin try, and we have end try. That encapsulates the code inside the try block. Now, typically a transaction wouldn't just have one insert statement in it. The transaction is meant to combine two or more actions together. So let's say, for example, we want to insert this employee, and then we want to assign this employee some sales records or something like that. To keep this demonstration simple, though, I'm just going to have one insert statement. The catch block is going to be used to roll back the transaction. If an error occurs. Now, how do we know if an error occurred on an insert? Well, what we can do, one of the things we can do is to find out how many rows were affected by the previous query. So if we can use this system variable that we learned about in the last video, we have row count. And if it is less than 1, then I'm going to throw an exception. So this example of conditional logic here, we have an if statement. Now, because there's only one action taking place, I can just have it here follow after the if statement. I'm going to raise an error, and the error is going to say insert failed. Now, if your if statement contains more than one line of code, and this rule follows in C# as well, right? You are familiar with this, that if you have multiple lines of code, you need a code block. But remember that there are no brackets, no parentheses enclosing code blocks in TSQL. So we would use begin and end to encompass more things. So if we wanted to say print a message and raise an error, then we put them both in a begin and end for the if block. So begin and end are taking the place of the braces around the code block. But we only have one line of code, so we don't need any of that. We're saying if the row count is less than 1, then we're going to raise an error. If we raise an error, then we're going to roll back the transaction, because raise error forces us into the catch. Now, this is a really simple example. This thing is going to raise an error on its own. We don't manually have to do it. But it's also useful for example, if we're performing a delete. So let's try this. So I'm going to have this succeed, and then we'll perform a delete. So I'm going to try to delete employee number 12, but if it didn't work, then we can say delete failed. So let's execute this, and we'll give it a try. So we say 1 row is affected and 0 rows affected. Now, the reason why we don't actually see the error message is because the catch block handled it for us. So we only see the error message if it's unhandled. If you use raise error on its own without a try catch, then when an error is occurred, it will halt execution. The catch is there to keep things moving. Now, what about the rollback? We can use this to prove that it did actually roll back that transaction, because if we see 1 row affected means that the insert worked. 0 rows affected means that the delete did work successfully, but it didn't delete anything. The raise error forced us into the rollback, which means that Ed Z here, even though he was successfully inserted, should be removed again from the table. So let's verify that. You can take a look at our employees, and you can see that we do not have this record. So the insert worked, the delete didn't delete anything because we don't have an employee 12. So raise error there caused the rollback to succeed. Now, if we're actually interested in seeing the error message, even though we make it into the catch block, we can use a function for that. So we can print out or display in the results set the error message that was causing us to go into the catch block. In order to do that, we can use select to display it in the results grid. Let's give that a try. Error message is a built-in system function that returns the message that came from the error. All right, let's execute this all again. We'll scroll up here to the try block and execute. So we've got 1 row affected and 1 row affected. Now in this case, the delete here did delete employee number 12. We must have made it up to that count in the employee IDs. So I've been inserting employees for a while. We must have made it up to 12. Let's execute it one more time. Here we go. So this person would have been employee 13. So we can see that when we get into the catch block, it displays the error message from raise error. That's delete failed. If we use print instead of select, it will go into the messages pane instead of into the results grid. Let's try that again with the print outcome. You can see now the delete failed message will have been printed to the messages pane. So we've got 2 different ways to get output. We know about selecting things, obviously, that gives us a result set object, or we can use print to print to the messages pane. Let's move on to our next TSQL topic. On this slide, we've got a list of familiar concepts that you studied last term when you took Database Essentials. So on the left, some typical SQL commands that we've been working with. Create to create tables, and then select, insert, update, and delete. And on the right, some concepts that we're familiar with. The first is data types. So we know that each field in a table has its own data type, something like int or varchar or bit or date time. So we're familiar with the use of data types. The idea of null when data does not exist. We've looked a lot at date manipulation, so things like date add and date diff, and using get date. Sorting and ordering, using an order by line in a query. And filtering using the where line. Filtering using the where line includes the concept of Boolean operations or comparison operators. So we want to know, if a value is greater than or less than or equal to another value. Or we did pattern matching with like. All of those things encompass filtering of records. We talked about subqueries and how you can use a subquery to retrieve a value, which can then be used in the where line of the main query. We learned about concat to build strings, and we also have this last topic here, format or substring are other ways to work with string and numeric values to output them in a user-friendly way. So concat is something that you've definitely looked at before. You may have had a chance to use format or substring to manipulate how the output is generated. So these are things that we're coming in already knowing. Now, if you want a little bit of practice with format and substring, please check out exercise that is posted in this week's folder because there are some questions that ask you to format certain things. So the format command in SQL is used with numeric values. Let's get an example. Here's our employees, and we can see how when we create the employee salary, the field is a decimal data type, and by default, it just shows us the number with the two decimal places. But if employee salary is a currency value, it's money. So one thing that we can do is we want to format the employee salary. So format works with numeric data types to format them in a specific way. Let's say emp first, emp last, and emp salary. So we'll cut down our data set a little bit. And instead of showing the salary as it is stored, we want to format it as currency. So I'm going to call on the format function to format emp salary. And we can specify a C for currency. It uses this built-in currency value. So if we execute this, we'll see how the currency is now formatted in a typical Canadian way. Now, depending on your settings, you may have a different format for currency. You can also specify a locale. There's a third parameter for that. If we check out the documentation for format, it gives you lots of different examples of ways that you can format things. So here's the Microsoft documentation on formatting. If we skip down to examples, you'll see that there are format examples for dates and for numeric types. So we can use N for number format, G for general, C for currency, and the third parameter allows you to put in a local. So whatever locale your computer is set to, you can change that if you want to format it differently. So if you want to format it as British pounds, for example, you can change that as well. This one here uses the German culture, and you can look up different codes for cultures as well. It's important to remember to give your columns aliases. As soon as you apply any kind of function or changes, we need to use the as to give our column a name. Later, when we access these result sets from a client, if you have a column that has no name, then you're going to have no way to reference and get the values. So it's really important that all the columns have names. I'm going to execute that and make sure that we get an appropriate value. Another example that we can do is with substring. Substring can be used to get a part of a string value. So there are a bunch of different methods that you can use. Substring is the main one. It allows you to specify where in the string to start looking and how many characters to take. So for example, if I wanted to get the first initial out of the last name, I'm going to select employee first so that we know who we're looking at, and employee last. And then I'm going to put in the employee's initial for their last name. So we're going to use substring and say, look in employee last field, start at position 1, and take 1 character. Notice how when we're referring to the field, position 1 is the first one. So it's not like an array where you start at position 0. 1 is the first character. So we're executing this. You can see how it gets the first letter. Now, if you wanted to do this in a quicker way, Another one that you could do is a function called left, which takes a certain number of characters starting from the left side of the string. Or if you want to go from the right, you can use a function called right as well. I'd encourage you to look into those. We can use substring to build up all different kinds of strings. So if we take a look at our employee table again, consider using substring to build the employee number. How would we do it? We could go into the employee start and determine what the last 2 digits of the year are. And then we could go into the employees first and get the first, and go into the last name, get the first character, go into the title and get the first character there, or the department code, or however it was that we made this up, and use the combination of substring or left and format to get the values that we want, combine them together to make that emp number field. It's a very powerful thing that you can use. Now, some database administration things that we can use to extend those existing concepts. We talked a little bit already this term about using alter. Typically when you're just starting out and we're learning about create, we say, if you have to make changes, just drop and recreate. That's a little bit easier. But, in production, or, when you have a lot of objects that depend on each other, that's not easier anymore, because if you have a table and there are, all these different procedures and functions and other tables that reference it, then it's not just that easy to say, well, just drop it and recreate it, because everything's connected. So we need to learn a little bit more about how to use alter. We've already talked about using alter to change some of the constraints. You can also use alter to add columns or change columns. Typically, you can use alter on any object that you can create. So once we get into making other objects like functions and procedures, I'm going to give you more examples on how to use alter when we're making changes to those objects. There's also a syntax that goes create or alter. It combines both of those. Unfortunately, it doesn't work for tables, but it does work for other objects such as procedures, where you can use a create or alter procedure that will create a new object, or if the object already exists, just change it. The logic of determining whether it exists or not is built right into the statement, but it doesn't work for tables. So how do we do this for tables? Well, for tables, we need an if statement. I'll show you an example of that in a minute. Usually there's one of two things. We can use this shorthand that says drop if exists, or we can do an if statement that says if the table exists, then drop it. So both of those things work almost the exact same way. Let's get a new query going here. The typical way of doing it is we would say if exists, and then we use a subquery to determine whether our object exists or not. And if it does, then we're going to drop it. So let's say, for example, we want to try dropping our employee table, but we want to make sure that the table exists before we try to drop it, because we know if we try to drop something that is already gone, that's going to cause us an error. So in order to avoid errors, we want to drop table employee only if table employee already exists. So how can we find out if it exists or not? In the subquery, I'm going to write a statement that selects everything from sys.objects. Now, before I put it in the subquery, let's take a look at sys.objects. This is a built-in view, and we're going to talk more about views next week, that shows us all of our user-generated objects in the database. So there's a lot of things in here. Typically, we use a where line to find our table. But if you look down here, there are some of the objects that I created. So we have a primary key constraint, a foreign key constraint, a unique constraint, a couple of defaults. This is why we name things the way that we do. So If we're looking in here, we want to find out if employee exists, and here it is. That's the employee table. If we look across, we can see that it's a user-created table. If we want to find out whether that particular table exists, we're going to look for the employee object name. Now, because the names aren't necessarily unique, what we want is the object ID. How would we know the object ID? Well, we're going to use a built-in function to find it. We know that our where lines should always refer to primary keys when we have them. So we're going to look for something like this, where the object ID equals, and then we're going to use this object ID built-in function that looks for our employee object. So this gives us the one result that we want. If we don't have a table called employee, then nothing will come up. So this is our subquery that we put in. Exists will return true if we have a record in the subquery. So true if the employee object exists, and then we drop it. Now the drop if exists command works the same way. It's not as widely supported, but by now our newer versions of SQL Server will support this. So we can say drop table if exists, and we just put in dbo.employee. So that will allow us to test to see if it exists, and if it does, drop it. If it doesn't exist, the drop command is skipped over. So the use of exists, as I mentioned, it checks to see if a result set is empty. We often use it in if conditions or in a subquery with where logic. When we're using an exists in a subquery, it will give us a result set, and then our main query will look in that result set to determine whether the thing we are searching for is found there or not. So let's do an example using exists in the where line. Before we start, I'm just going to refresh my employee department table because I've been making so many changes to it and I just dropped the employee version of it. So I'm going to recreate that database before I continue. Okay, so now that I've recreated my employee and department, I'll just move down here a little bit and we'll take a look at exists in the where line. So I'm going to create a query that shows us information for departments, but we only want to show departments that have 2 or more employees. Now, one of the ways that we can do this is by performing a join between department and employee. But the thing about the join is that it retrieves data from both tables, and if we don't need any of the data from the employee table in the projection, then we're not necessarily needing it to be part of the join. So we can perform the select just from the department, but in the where line, we want to say where the count of employees is 2 or more. So I'm going to look and abandon this query for a minute and write a different query that tells us how many employees are in each department. So I'm going to select a count of employee IDs as employee count from employee, and we're going to say group by department code. Now I'm going to briefly put department code in the output, so I'll execute this. So we have 3 employees in accounting, 4 in information systems, and 1 in marketing. Now I don't need dep codes in the projection. But if I want to select department information where the count of employees is greater than or equal to 2, I'm going to put in a having line. Having greater than or equal to 2. So now we see that employee count is 3 for one of them and 4 for the other. Now if we want to put this in the subquery, I'm going to correlate the subquery so that it only picks departments if their department code shows up in here. So in my inner query, now this is a review, we've done correlated subqueries before, I'm going to add a where line that says where the employees department code equals the departments.department code. Now that this is a correlated subquery, we've got to put it in the where line. So we use exists, and I'm going to take this entire subquery and we'll put it right in there. Let's get some formatting going here. There we go. So the correlated subquery takes the information from the department, that is the department code. For each department code, it finds the matching employees department code, groups them all up, and only returns a result if the count is greater than or equal to 2. So for departments that do not meet this having criteria, they won't be included in the main results. So exists is just a true or false. But the true or false is, does this particular department code exist in this particular result set? Does it return anything? Yes or no? Now the reason why this works is because my subquery just returns one value at a time. It's going to happen once for every department. So for every department code, the department code goes to the subquery and it will either return the count, but if the having criteria isn't met, it will return an empty result set. So the exists would be false for that department code. Now, so far, all the subqueries we've done have been that, returning one single result. The next example uses a subquery with in. Now, we're familiar with in. We can do something like this where we would say select all from employee where, let's see, employee title is in a list of values. So when we use in, we have a list of values. We can start at this starting point, show programmers and managers. We can use a subquery here to generate the list of acceptable values. So let's take a look at a list of acceptable department codes. My subquery is going to select department codes from department where the department budget is greater than, say, 180,000. Now, let's take a look at departments, and we can see what we expect to come back as the result. Department budgets greater than 180,000. Accounting, information systems, but not marketing and not personnel. So the department codes that we'll see are accounting and information systems. So if my query asks, which employees work in a department having a budget greater than 180,000. Again, we can do it with a join, but because we don't need the information from departments in the projection, we don't need to perform a join. What we want to do is we want to select employee information. We can use a correlated subquery to give us a list of valid departments and find all of the employees where the department code is in that list. Let's move this query into our in statement. Now this query, when it's highlighted, gives us this result list. That result list is used in the in statement. It's almost as if our main query says, select all from employee where department code in ACCT or ISYS. So we execute this main query, and it shows us all of the employees from those two departments. Now the last example on this slide says union. Union is used to combine the results of two or more select statements into a single result set. Now when you're performing a union, you have two different select statements and you're going to combine them into one result set. Now here are two different select statements. If I execute them separately, you can see I get two separate result sets with different columns. If I wanted to put them into one big result set, then I have to make sure that both of them have the same columns, because there's no way to combine these two things into a result set when they look so different. But I can make them look similar by modifying the projections. Now I can't get everything, obviously, because departments have 3 columns and employees have more than 3 columns. But let's take a look at how I can modify the two projections. If I can say select department code and department name as name. I want an alias here as well. So we're going to have 3 columns, code, name, and we'll call it money. Now I'm going to have a similar projection for employees. This is employee department code. Same column names. Let's say for the name field, I'm going to combine emp first and emp last. So we're going to concatenate emp first, a space, emp last as name. And I'm going to use their salary as the money field. Let me just make this a little bit bigger so we can see the entire thing. So here are 2 different select statements, but you can see that now we will be able to combine them into one result set using union, because they have the same 3 columns and they have the same 3 data types. So let's execute this, and we'll get one big result set for everything. Now when you combine a result set like this, you'll see that this one is a record from the department table, and this one is a record from the employee table. So it combines it all into one big result set. We can order it. For example, if I order it by the money field, it will treat it like one big result set. You can see that the department fields here, marketing, accounting, information systems down here. Personnel is another one that came from the department table. So we're combining it into one big result set. It's really hard to tell which one came from which table. Now, one way that you could know is to create another column indicating where it came from. So for example, if I create another column in both projections, I'm just going to select the letter D for department, and we'll call that column source. In the other select statement, I'm going to say E as source. So I'm just selecting a literal letter D here or a letter E here. Now I have an indication of, okay, this one's an employee, that one's a department, this one's an employee, that one's a department. So I'm just selecting a literal to go in each one of those. So this is an example of how we can create one result set out of multiple places without having to perform a join. Because performing a join here wouldn't make too much sense. So those are just a few things that we can learn a little bit more about the basics of TSQL, different things that we can do as far as manipulating tables and using subqueries to customize our results. So next week we're going to start looking at different programming techniques in TSQL. We're going to look more at if statements, we're going to look at variables and data types and iteration constructs, and we're going to get more into some TSQL programming. So look for that to come up in the next video. Thanks for watching and have a great day.